A particle travels in a straight line past through the fixed point O. The displacement x meter of the particle t second after it passed through O is given by this x equal to phi t plus psi t. So the question asks us to show that the particle never at rest. At rest, we know that velocity equal to 0. So we know that the v is dx dt. Then it will be phi plus cos t. And then the a will be the dv dt. Then it will be the negative sin t. Okay, so for a, okay, we know that the velocity is the phi plus cos t. Okay, so we need to show that it never be 0 because we know that the cos t is between negative 1 and 1. When I plus phi, then we have the v is between 4 and 6. Okay, so v greater than 0. Okay, v always greater than 0, so v never becomes 0, therefore never at rest. Okay, particle is never at rest, never at rest. And then for question part B, distance traveled between t equal to pi over 3 and pi over 2. Okay, so for this one, okay, B, we want to find the distance between time of this and this. Okay, so when t equal to pi over 3, x equal to phi times pi over 3 plus sine pi over 3. So pi is 180 over 3 is 60. So sine 60 is square root 3 over 2. So 5 pi over 3 plus square root 3 over 2. Okay, plus square root 3 over 2. So when we have the pi t equal to pi over 2, then this x equal to sine 90 degree is actually 1. So it will be 5 pi over 2 plus 1. Okay. So I think this one is greater than this. So the distance travel will be the 5 pi over 2 plus 1 minus the 5 pi over 3 plus square root 3 over 2. Okay, so we will have the 1 over 5 over 2 minus, wait, this one I just multiply with 3, multiply with 2, so 15 minus 10, then will be 5 pi over 6 plus 1 minus square root 3 over 2. Okay, yeah. So it will be 5 pi over 6 plus 1 minus square root 3 over 2, square root 3 over 2. So this is 2.75. 2.75. Yes, this is the distance. C. So find the acceleration when time equal to 4. So C here, when t equal to 4, a equal to negative sine 4. Okay, so we have the negative sine 4 angle unit radian. So 0.7 0.757, okay, meter per second. Yes. Find the value of t first at is minimum. So minimum when we have the dv dt equal to 0. So that means the d here, the dv dt equal to 0, that is the negative sine t equal to 0. So we have the sine t equal to 0. So we will have the sine t equal to 0. Then we have the up sine 0 is 0 or pi. So the time equal to pi. When time equal to 0, okay, then the velocity will be 5 plus 1, 6 cos pi negative 1. Yes, okay. So the t equal to 0 or pi, and then we have the second derivative, that is the negative cos t. So second derivative, okay, when t equals 0 will be negative cos 0, that is the negative 1. Less than 0 is maximum. And we have this t equal to pi, negative cos pi, it is 1. Greater than 0, it is minimum. So minimum, okay. So we know that t equal to pi will be the answer. Actually, for this one, we have another method to solve it, which I think is easier compared to the method that I use here. That is, we sketch the graph. Okay, so for D, we use method number 2. So we know that this is the V, is the 5 plus cos t. 5 plus cos t, okay, the graph will look like this. Cos t plus 5. So we have the cos t plus 5. So this one, we have 0 plus 5 is 0, and then 4 minus 1 will be 4, and then plus 1 it will be 6. Okay, so we will have this is 4, 5, 6 cos will be something like this, and repeat again. So this one will pi, and this is the 0 pi, and then this is 2 pi, 3 pi, and 4 pi. This is the time, and this is the velocity. So we have minimum when t equal to pi. So minimum when t equal to pi second. Okay.